In this section, we're going to talk about a very important issue, safety. Hello, Scouts. In this section, we're going to talk about safety. I'm going to show you some of the wounds that you can get if you're not careful. I'm also going to describe ways that you can protect yourself. We're going to talk a little bit about grounding and lightning protection and a few other topics. Please pay attention. This is an important subject. We will start by examining this chart. What it basically shows is how little current can do so much damage. It can stop the heart, stop you from breathing, and this is at 100 volts. I might remind you that that's what comes into your house. It's a 120 volt system, and it can do pretty much anything to you. This is an extreme example of what's called an arc flashover. You can see the gentleman in there. He has protective gear on because this is a demonstration, but I've actually seen such a thing happen in a real workplace. The center of this arc is extremely hot, and it will burn, and it's not a lot of voltage that's doing this. So this was a starter example of what can happen. Here we have an example of an electrical hand burn. You can see how deep and how red this is. Now, electrical burns are a lot different than a regular burn because they're normally from the surface down. Electrical burns penetrate deep into the tissue, and because of this, they're far more seriously. As a matter of fact, a doctor who has to treat these is usually specially trained because of the nature of the type of wound. It's deep and it's serious. I hope I'm scaring you to pay attention to safety rules, because this is what could happen. One of the most important things that you can do when you're working with radio is use your brain. Doing things without thought or knowledge can hurt you. I have a favorite quote listed up here. Life is hard. It's even harder when you're stupid. That's by John Wayne. And I want to remind you that just because you're smart and intelligent doesn't mean that you can't be stupid. Here is one of the best rules that you can follow. Never work on a circuit while power is applied. One little slip of a tool, hand, any one of a number of things, and you can get hurt really bad. Okay, now we're going to talk a little bit about outlets and circuits. And generally this is going to be for 120 volt system, residential systems. If you look at these pictures, you'll see on the left one where so many wires are stuck into one outlet socket that the breaker would normally open the current if there was too much current. But what you have here is a real potential for fire. If you don't think that'll happen, I can tell you personally, I saw it happen when I was using a power saw. And when the power saw stopped, I looked to the right where it was plugged into the wall, and the cord was burning. It was actually on fire. Now, there were a couple of other things that were involved in this. For one, the breaker in that system was way oversized. If you look to the right, we'll see a two-pronged plug going into a two-pronged outlet. That's not a problem, because the equipment that's probably hooked to is something called double insulated. Today, in the modern circuit of houses, when they're wired, they're required to wire a grounding circuit. And that grounding circuit has one copper wire that goes all the way back to the panel and all the way back to earth. Sometimes when you use equipment that has a three-prong outlet and you can't get it into this two-pronged outlet, they want to use an adapter. As soon as you do that, you have no ground at all. So you must be very careful what you're doing and how you handle the ground. Sometimes in older homes you won't find the three-prong. So be aware that when you use the adapters, and they are sold by the hundreds, they're out there, what you're doing. It's not safe. There is another device called a ground fault interrupter. That ground fault interrupter will sense a ground and automatically disconnect the power. These are great if, and I say if, they are installed correctly, because you have to have a good electrician do that, or you follow the instructions to the letter. If you do not hook those things up right, they will not work properly. There are ways to test those. So you've given a brief introduction to using the circuit in your home.
There's a myth that electricity follows the path of least resistance. It actually follows all paths back to its power source, some just stronger than others. The part of the body most affected by electricity is our heart. If we come in contact with the same power in an outlet in our house, it will find a way back to ground. If it's a really good conductor, such as a puddle of water, there will be a really strong path for electricity, and that path might travel right through our heart. Without going into technical detail, let's say there's only a thousandth of an amp, 1 milliamp, flows through our body. You probably wouldn't feel it. Up to 5 milliamps, it's actually considered safe. Between 15 and 20 milliamps through your body, you have a very painful shock, and you may not be able to let go because your muscles will contract. At 50 milliamps, your heart will convulse, and you usually die from electrocution. 1,000 milliamps, which is 1 amp, can electrocute 20 adults at the same time. Hopefully, if you have respect for a simple home electrical outlet that can deliver 15,000 milliamps or more. Whenever you're working with radio equipment, or any equipment for that matter, unplug the equipment first. Leave the hot service work to someone who knows good safety practices and does it for work. Unless you know the special precautions necessary when working energized equipment, don't do it. Equipment should be turned off and unplugged when you work on it. Sometimes it may be necessary to turn the power off on a circuit breaker. Don't hesitate to do that. Make sure it's okay with other family members, and never let anyone else turn the power off or on for you. You need to always confirm with your eyes the status of that circuit breaker. In professional work, we call that lockout tagout. We actually put a padlock on the breaker so nobody can turn it back on while we're still working on that equipment. Just as you're not effective doing homework when you're tired, it's not safe to work with electricity when you're tired also. Just don't do it. Never wear headphones when repairing equipment. They could create a path to ground for electricity to travel right through your head. If the surfaces provide a path to ground, the shortest or strongest path is through the chest and heart. Not a good thing. Instead, if he puts his hand through his pocket, the shortest path to the ground would then be down the side of his body, through his leg, and then out to ground. This can be a very bad shock. It might even knock him out, but it may not kill him. Having electricity go through your chest creates a likely scenario for death. Be careful when working with electricity. Death is permanent. One of the most important safety features of your home ham shack is how the station is properly grounded. Being grounded may not have meant much up to this point. Now it means something a whole lot better and safer. Let's look at how grounding occurs in your home. There's a heavy-duty wire connected between the transformer and your home. This wire carries 120 and 240 volts. It also carries a ground wire that is connected to the earth ground near the pole or the underground transformer. After it's attached to your home, a main power line is routed through the walls to a circuit breaker box. That box redistributes the power, both 120 volts and 240 volts, throughout your home. Regardless of the circuit voltage, each includes a ground wire that is attached to the circuit breaker box, then routes outside the box to a ground rod, the same earth ground that the power pole and underground transformer is attached to. When you look closely at an electrical outlet, each socket has an individual ground receptacle that is attached to the overall electrical ground system. When you plug an electrical equipment into the three-prong outlets, they become connected to the earth ground if everything is wired correctly and the connections are properly made. Every ham shack should have an additional earth ground system. A separate wire is run from your operating table down to the ground rods that you have pounded into the ground some 6 to 8 feet. Most radio shacks need more than one of these ground rods. The attachment at the ground rods looks like this. Grounding will be different depending on the kind of soil you have. Loam and clay is good. Sand and rock, not so good. Some ham shacks have separate ground wires attached to the home's cold water pipes like this one. The idea is that the cold water pipes eventually run through the earth ground. Hot water piping may be isolated at the water heater from the earth ground, so they should never be used for this purpose. Natural gas lines also should never be used for grounding. As homes are using more and more plastic plumbing, we recommend hams use separate ground rods unless they know for sure that the materials used for the piping will, in fact, be earth grounded. Too many deaths have occurred over the years from people not wearing proper protective equipment when climbing towers. Another situation that occurs is when accessing the roof of your home to set up the antenna. You must steer clear of power lines and never have your antenna near such a line. Here's some other important safety factors. A 3-prong plug like this is included in most ham radio equipment that plugs into an outlet. The prongs need to be in good shape. The single round prong will connect the radio equipment to the house's ground system. Never use a plug that has had its ground prong plug cut off or somehow removed. If equipment came with a 3-prong plug, it was designed to have all 3. If they are not, you could be exposing yourself to the risk of serious shock or electrocution. Sometimes people will use these adapters to keep from cutting the ground planes, but this can be very hazardous too. No ground. Another one we see too often is a power cord with insulation that has broken away. This cord should either be repaired or discarded. Repair does not include just using electrical tape. This area is weakened, and if the internal insulation hasn't broken away yet, it soon will. Repair will include replacement of the molded plug in a manner that has the proper strain relief. One comment about ground fault interrupters, GFCI outlets. These are being used more and more in newer home wiring, and they can be installed in older homes too. They are also a good idea for ham radio shacks. GFCIs will break the circuit much quicker than a circuit breaker in your home. You could easily die from a shock before the panel breaker would trip, but a GFCI trips very rapidly with very little current flow to the ground. To do this, they have an electronic monitoring circuit that should be tested, and that's why there's a little test button and reset button on every unit. Some areas now require AFCIs, arc fault circuit interrupter breakers. These are located at the main breaker panel, designed to protect against electrical fires, as opposed to GFCIs which protect against ground faults. Here is a handy device you can use to test all the 3-prong outlets in your ham shack and your home. This will tell if your outlets are wired properly and in what shape the mechanical connectors are inside the outlet. The red test button on the tester also serves the same purpose as the test button on GFCI. Now we'll change to the topic of lightning, the scourge of many ham radio operators. Here's a map of the continental United States showing the lightning density for the last 10 years. How many of you live in areas that show up in the upper end of the scale? Orange, red, dark red, purple? Our particular council is in the lightning capital of the country. Let's take a look at a typical ham radio station. The heart of our system is the radio. A critical part of the system is the antenna. Our antenna could be a wire or an expensive tower setup like this. Some hams will set up their metal rain gutters to serve as the antenna, or maybe even the aluminum flagpole up front. For this discussion, we'll use the tower. Even the power line coming to the house is part of our station. You'll see why in a minute. Ham radio operators usually have lightning arresters in their antenna feed lines to theoretically keep a lightning strike from the radios. I say theoretically because if we think we can totally control the nature of lightning strike, we're giving ourselves too much credit. Lightning arresters are a good precautionary step with no guarantees. That said, we should have them in our system. The most important element for safety is our grounding system. This includes not only how we ground our equipment antennas, but also the geology of the ground itself. Damp, dry, hard, soft. We don't have time to get into this in depth, but the design of our ground system is critical not only for our safety, but in many cases on how effective our radio system is at sending and receiving a signal. You can see here that a ham radio put a lot of work into making a good ground at the base of their antenna. He also did a lot of engineering to properly feed the antenna lines to the house, another very important part of the ground system. Even more, he set up his Radio Shack bench with grounding measures. Let's watch what happens, at least theoretically, when lightning strikes our ham shack. One of the most common ways it can happen is when lightning strikes the electrical power lines. Energy from the strike can travel down the line looking for a ground. It is instantly traveling to the nearest ground, which in this case could be the grounded entry point to our house. Another high-risk entry point is through our antenna. The best case scenario for this energy is to travel down the metal tower and into the ground system at the base of the antenna. Some energy may try to go down the antenna feed line, but if our lightning arrestor does its job, it will bypass the ground. As we said, there is no guarantee of this. Now let's look what happens if there isn't a good ground system. If we didn't have adequate grounding around the base of the antenna, or if the lightning arrestor didn't work, the energy would travel down to the nearest ground, which would likely be down and through the radio and into the radio station's ground rod or the building's ground system. Your radio fries in this case, and if you're near it or touching it, you might fry too. Since there is no good ground at the base of the antenna, the lightning finds the closest path to ground through the radio. If anyone thinks that power from a direct current DC power supply is safe, just look what happens when you short out a car battery. Remember our chart earlier that showed how little current was required to kill you? 12 volt direct current is much less voltage. That is one factor. But look at this chart. This automobile battery has over 1,000 amps, plenty of power to kill you if it can go through your heart. If you short the positive terminals of this high current hand power supply with the negative terminal, you'll get the same results from that battery, and it can severely injure or damage the supply beyond repair, let alone the expense associated with buying a new power supply. Carefully observe the polarity of these terminals. It's pretty universal that red means positive and black means negative. If you ever encounter a power supply that isn't set up with these colors, have second thoughts on whether you should use it.
Now the basic idea with grounding is to give the electrical current a path to go to ground. Now in your house you have a little AC outlet plug, and there's two types of wires. There's what they call a neutral, and then there's a grounding circuit. The grounding circuit is hooked into the box and has a copper wire that goes outside the house and is driven down into the ground about 8 feet with that copper wiring. That's the grounding part. So if it's hooked up right, if there's any short, the current's going to go back into that wiring system and back down to the ground. Hopefully not through you. Same way with direct current grounding. A radio operator will add another ground rod and connect all of their station equipment cases to it as well. It provides additional safety grounds, and it will make sure that any stray RF radio frequency currents also go to ground. Then there is the issue of antenna grounding. Use lightning protectants where antennas enter the house. These bleed off static electricity. No protection to a direct strike. However, when we're talking about antenna grounding, we want to be sure to get experts to help us do it right. Just because the power is off doesn't mean it's safe. In the next slide, we're going to look at a little bit of what a capacitor can do and how much energy it contains. Alright, here's another safety tip. Do not connect power to a circuit until the circuit is finished and you have carefully checked your work. This is very important because it's easy to make a mistake. So double check, double check, double check. That's actually triple check. But you get the idea. Check your work and be careful. Now, if you smell anything burning, what you should immediately do is disconnect the power and examine your circuit to find out what went wrong. And here's the reason why. Small fires get big very fast. Here are some more things to think about. Keep your work area dry. Use safety goggles. You do want to see, don't you? Capacitors hold power even when power is off. You saw a demonstration of that. Cutting wire can send small pieces flying. You don't want them in your eye. Work in a well-ventilated space. Chemicals can be dangerous. Acid fluxes, glues, batteries, all the stuff you use in electronics isn't exactly friendly to the body. And you want to have safety equipment available. Safety with RF energy. Radio waves can burn, so you never want to operate your radio with the cover off. Radio frequencies can cause burns and cancer. If you don't think so, look at your microwave again. Your eyes are especially sensitive to radio frequencies. Very sensitive if we're talking about microwave frequencies. Hams are required to conduct a routine station evaluation to verify safe operation. There are numerous procedures, and the rules for doing this are well documented. One area that deserves attention in safety is antennas and towers. They're usually high in the air, and you want to make sure that they're never located by electrical power lines. They can fall on the line in any direction, never over or under power lines. You could be electrocuted when using that radio. Be careful when you climb. Those towers and roofs are sometimes not very friendly. Every antenna needs lightning protection, and the best way to do that is to find an expert to help you. You want your antenna pole connected to ground rod. You want to disconnect your radios when lightning is in the area. If lightning hits your antenna, it can travel down your lines to the radio. It can also hit the power lines and come in through the house that way. Make sure your antenna and radio are grounded to a good earth ground. Don't operate it in thunderstorms, unless you're crazy.